Okay, so today we're going to continue down this path of looking for patterns and finding formulas. And the good news is that since you are so good at finding the easy ones where it goes up by the same number every time or goes down by the same number every time, that we're going to graduate up to more complicated formulas. Okay? Since you're so good at that other one, we'll just challenge you a little bit. And so we're going to start out with something that is called the handshake problem. And the handshake problem goes like this. If you were in, let's just say, the classroom or a party or whatever with a bunch of other people, and everybody, okay, Riley's ready to party right now. You guys missed that. And everybody in the room shook hands with everybody else. How many total handshakes would there be? Okay? And we're not doing anything weird. What I mean by that is if Tony shakes Brooke's hand, then Brooke's not going to turn around and shake Tony's. You know what I mean? That counts as just one thing and then we're done. Okay? Not like, I'm going to shake Reed's hand and then we're going to stop and then Reed's going to shake my hand again. That's just, yeah, that's a little bit different. Just shake hands once, okay? And so the question is, can we figure out a formula so that we could determine how many handshakes there would be in this room if there are 4, 8, 13, 17, 20, there are 27 of you in this room. So how many handshakes total would we end up with? Yes? Okay, so you're saying 26 times 27 because of what we just talked about. If I shake hands with someone, they're not going to shake hands back with me, right? So she's going with 26 times 27 because the first person will shake 26 hands and it goes down from 1 there, okay? So there's a good guess, and that is going to help us in a second, yeah? Okay, so Tony is taking that idea and saying the first person is going to shake how many hands? 26. And then you said the next one would be 25 because the next person would shake everybody's hand except for the one. Okay, and you want to add all these together. 26 plus 25 plus 24 plus 23, dot, 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 all the way down to 1. And if you added all those up, that would get you the answer. Okay, so that's a possibility. Any other ideas? Colton? Times what by, take this and times it by 2? No? Okay. Okay, so we got some good ideas here that are sort of based on the situation of going down 1 every time. Let's model this problem just like we have been in the other ones where we're coming up with formulas by looking at a simpler case and seeing if we can come up with a pattern. Okay? So let's start with a simple case and go from there. So what is the fewest number of people you could have in the room and get a handshake? Okay, 2. How many handshakes would there be? 1. How about if there are 3 people in the room? How many handshakes would there be then? 2. Everybody agree with that? Yeah. Yeah? So if there's 3 people in the room, so I'm going to shake Lauren's hand. And then I'm going to shake Greg, because they're going to shake each other's hands also, so that there would be 3. So let's model this, okay, with people. So if we have 3 people in the room, there's our 3 people. How can we show the 3 handshakes that would happen? Sure, arrows in between them. So this person shakes hands with them, they shake hands, and then they shake hands also. And so there's your 3 handshakes, right? Okay, so 3 people, 3 handshakes. How about 4 people? How many handshakes then? Let's make a little model here. So let's start with this guy. 1, 2, 3, right? And this is the idea that Tony gave us at the very beginning with the decreasing numbers there. So that person shakes everybody's hand, and then how many are left after that? 2 from here. This person shakes those, and then the one in between here has to happen also. So how many handshakes total did we get? 6. Okay? So 4 people is 6. So unfortunately, like I said, we're going to be dealing with some a little bit more complicated problems here. What is different about this than the problems that we were working on yesterday and today? There is a, not necessarily, there might still be a pattern, but Rochelle? Right, okay, so the other one, I love the way that you said the word common. The other formulas had what's called a common difference. They went up or down by the same amount each time. Does this have a common difference? No. So this, because this one went up by 2, and this one went up by 3, okay? So it's not necessarily that there's not a pattern, it's just that the pattern is going to be a little bit more complicated than the other ones that we looked at. Can you make a guess? Can you make a conjecture based on this so far? What it might be for 5 people?
10.
You're going with 10? How'd you get 10?
Well, because I'm from like times 2 and times 3 instead of yes.
Plus 2 and then plus 3, and so now you're thinking plus 4, which would give you 10, okay? Well, let's check that and see if it works. So if I now have 1, 2, 3, 4, 5 dots, this person shakes hands with 4 people, right? Then this person is going to shake hands with 3 people, which is what Tony was working on at the beginning. And then this person shake hands with 2 people. Okay, so I need to add 2 more handshakes on there, and then finally there's 1 handshake right there. Okay, so if we add all those up, you get a total of 10. Okay, good. So we have found a pattern that seems to work. The problem with this is if I want to go all the way up to the 27th person, I'm going to have to make a really big table here, right? Keep adding more and more numbers each time. Or if I want to use the pattern that Tony came up with, I have to add 26 numbers together. What I would like to be able to do is come up with a pattern or a formula where I can just plug in the answer right off the bat and get, plug in the number 27 right off the bat and get an answer. Does that make sense? Yeah? Okay, so what we're going to do in order to do that is we are going to break this down a little bit by looking at the model that we had. And so let me redraw some of the easy ones that we had, the beginning one. And that went like this right here. Okay, so now we're going to say number of people. And then we're going to change this and say segments. Well, let's change that. Let's stick with the handshake. Handshakes per person. Okay, so we're going to break this down a little bit farther here. I guess I didn't need to put the 1 dot there. So if we have 2 people right here, how many total handshakes does this person make? 1. And you can tell that because why? There's 1 line coming from that dot, right? How many total handshakes does this person make? Also 1, all right? And so the handshakes per person here is 1. Now if I have 3 people, how many handshakes per person do I have in this case here? How many people does this person shake hands with? 2. How many people does this person shake hands with? 2. And how many does this person shake hands with? 2. Okay, so everyone in the group ends up shaking the same number of hands. And in this case, that would be 2. How about with this one right here if I have 4 people? What's that? Each individual person. Okay, so what you're saying is the total handshakes, which we did on the other thing. Now that's important. ended up being, for this one, how many total handshakes were there? One. And for this one there were 3. Okay? And for this one there were 6. Okay. That's important. How many handshakes per person in this thing right here? 3? Because there's 3 segments coming off of each one, right? Okay? So that gives us a nicer pattern of numbers, because now you can see, hopefully, if this is n, based on what we talked about at the beginning of the class and yesterday, what is my pattern for handshakes per person? What's that? Yep, excellent. N minus 1. So if I have 2 people, each person is going to have 1 handshake. If I have 3 people, each person is going to have 2, so 1 less. 4 people, each person gets 3, right? And that makes sense because you're shaking everyone's hand in the room except for your own, okay? So here's where the tricky part comes, and I just have to sort of use my math magic wand to do this. Can anybody see how I can combine these 2 numbers to get these answers right here? So I have a 2 and a 1, and I ended up with 1. I got a 3 and a 2, and I ended up with 3. A 4 and a 3, and I ended up with 6. So these are my n's, these are my n minus 1s, and somehow I can do some math with them and end up with these numbers right here. Anybody see that? What is it? No? Okay, let me give you a hint. What would I get if I multiplied these 2 numbers together? Because we're talking about handshakes per person, I would get 2. What would I get if I multiplied these together? Then I would get 6. Right, and if I multiplied these together, I would get 12, okay? And so these numbers are close to these numbers right here, except for what did I have to do to them? Divide by 2, okay? So if I take this number here and this number here and multiply them together and divide by 2, then that will give me my answer. Do you believe me? So this number here is, we're going to use, instead of a specific number, we're going to use the number n. This number right here, instead of using these specific numbers, we'll call that n minus 1. And then after I get that, I have to do what? Divide by 2. So this is the formula that you would use to figure out the number of handshakes in a room. Okay? And do you see why that's a little bit more convenient than going 26 plus 25 plus 24 plus 23 plus 22 plus 21 plus 20 plus 19 plus 18 plus all the way? Okay? Because now that I know what this formula is, how do I figure out how many handshakes there would be in this room if you guys all got up and shook everybody else's hand? What? Let's try it. See if math actually works. Let's figure out the answer. What is this 27? What do I do with it? Multiply it by 26, because 27 take away 1 is 26, and divide that answer by 2. Okay? I'm going to do the math the easy way. 26 divided by 2 is 13, and then 13 times 27 is 153. So there would be 351 handshakes in this room if everybody got up and shook everybody else's hand, which is a good reason for us not to do it. That would be a lot of handshakes. It would take a long time. Right? Okay, these numbers here in this handshake problem have a special name. They are called the triangular numbers. And they come up a lot. You're going to see them a lot again, and so you should really circle that in your notes. Triangular numbers, that formula is n times n minus 1 divided by 2. And the reason why they're called the triangular numbers is because I can use them to make, wait for it, I said wait for it, triangles. Yeah, so my first triangle would have 1 dot in it, My second triangle would have 3 dots in it. My third triangle would have 6. And my fourth triangle would have 10. So this is 1, 3, 6, and 10. Okay? Does that make sense? And do you see why you're adding, we went +2, +3, +4. Do you see why I would have to add 5 to get the next number here? Because I would have to put 1, 2, 3, 4, 5 dots underneath the triangle. Okay? You guys are super quiet, which is great. I just hope you're super quiet because you're so fascinated by this whole thing that your brain is just processing
Yeah,
this
we're all
information.
processing.
Good, that's good to know, because Mariah over there was processing the back of her eyelids for a little while, so I was kind of worried, but I'm sure she was just closing her eyes so you could concentrate a little bit better? Yeah, okay, good.
Just trying to picture.
Trying to picture it in her head, all right, good deal. Okay. So let's do the assignment.
That went for me. Oh, it is.
You're meant to say, right? That's what you're meant to say?